Imagine sitting quietly in your home when suddenly, from across the galaxy, a blast of deadly radiation races toward Earth. No alarm, no chance to dodge, just an invisible wave of energy that could wipe out life as we know it. This isn't a sci-fi scenario, it's a real risk from one of the universe's most violent events, a gamma-ray burst. And there are stars out there primed to go supernova and unleash one without warning. What are gamma-ray bursts, or GRBs? Gamma-ray bursts are the most energetic explosions known. In a blink, seconds to minutes, they can release more energy than the sun will emit in its entire lifetime. We detect them as intense flashes of gamma rays from distant galaxies, some from billions of light years away. There are two major categories of GRBs: short duration, lasting less than 2 seconds, and long duration, lasting tens of seconds or more. The long ones are usually tied to the collapse of massive stars, when they run out of nuclear fuel and their cores collapse to black holes. Because they're so brief, we don't always catch them in the act. In many cases, by the time telescopes train on the region, the burst is over, leaving only afterglows across X-ray, visible, and radio wavelengths. Why GRBs are dangerous? What's so threatening about a gamma-ray burst? 1. Radiation overdose. Gamma rays are highly penetrating radiation. A nearby burst aimed at Earth could blast our atmosphere with lethal doses, destroying ozone and exposing the surface to harmful ultraviolet and cosmic rays. 2. Atmospheric collapse. The energy could break molecular bonds in nitrogen and oxygen, creating nitrogen oxides that catalyze ozone destruction. Without ozone, life gets exposed to the full brunt of solar UV radiation. 3. Mass extinction trigger. There's speculation that past mass extinctions on Earth may have been triggered by GRBs. Fossil records show sudden die-offs and strange chemical signatures that some researchers argue are consistent with radiation damage. But for GRB to harm us, it must be relatively nearby, within a few thousand light years, and be precisely aligned. The burst is strongly directional, like a cosmic laser. The progenitors. Which stars could do this? Not every star can produce a GRB. The candidates are rare. Massive stars, tens of times the sun's mass, that rotate rapidly. Stars with low metallicity, or low abundance of heavier elements. Binary systems, where a star gets spun up or stripped by a companion. Wolf-Rayet stars, hot, massive, and losing gas in strong winds, are often considered prime GRB progenitors. When their cores collapse, if conditions align just right, they can launch jets out of their poles. And if Earth falls in line, we're in the crossfire. One of the scariest nearby candidates is WR104, a binary system about 8,000 light-years away. Some scientists proposed it could produce a GRB someday. It's oriented such that it's speculated the burst direction might hit Earth. Later studies cast doubt on the precise alignment and timing, but the mere possibility has sparked headlines. Real GRBs we've observed. Although no GRB has been recorded as hitting Earth, we're watching constantly. Telescopes like Swift, Fermi, and Integral detect zones of GRBs per year. One famous event is GRB 980425, associated with a supernova, SN 1998 BW, in a galaxy 140 million light-years away. Another is GRB 130427A, one of the most powerful ever detected, seen across many wavelengths and lasting more than 20 minutes. Every detection helps us refine models, how stars collapse, how jets form, how radiation escapes the star envelopes. We learn where GRBs occur, how frequent they are, and how dangerous they might be for habitable planets. Could a GRB hit Earth? Let's examine the risk. Distance matters. To severely damage Earth, a GRB would have to occur within about 6,000 to 12,000 light-years, some estimates narrower. That's a very small region compared to the Milky Way's around 100,000 light-year radius. Directionality. Even if a star explodes, unless the GRB jet is pointed almost exactly at Earth, we'd miss the brunt of the radiation. Frequency. GRBs are rare. In galaxies like ours, one might occur every few 100,000 to a million years. Despite these factors, the possibility is non-zero. Some scientists even recommend monitoring candidate stars and cosmic events as part of planetary defense. Signs we should watch for. So what signs might alert us to an impending GRB? Massive star dimming or instability. A star showing erratic brightness, shedding massive amounts of gas, or spinning faster could be nearing core collapse. Coronal changes. Unusual spectral shifts or gamma or X-ray emissions from a star could be heralds. Neutrino bursts. Some theories suggest neutrino detectors might catch early bursts of neutrinos just before the gamma rays arrive. But realistically, humanity would have very little warning, minutes to hours, not years. Even then, we might not survive the effects, especially on the side facing the burst. No known star is currently confirmed to be an imminent gamma-ray threat to Earth, but the idea itself, that a cosmic explosion from across the galaxy could end life here without warning, is chilling. We live on a fragile blue planet protected by layers of atmosphere, magnetosphere, and distance. But nature doesn't guarantee safety. If this video made you look at the sky differently, hit that like button and subscribe to Cosmic Crunch. Drop us a comment. If you knew a star out there was going to explode someday, would you want to watch it? And don't miss our next video. We've got more cosmic threats, weird worlds, and mind-bending mysteries ahead.